This third problem, 28, requires that you first convert the equations into standard form. What do I mean by standard form? This does not look like y equals mx plus b. You cannot look at this and tell what m is. You cannot look at it and tell what b is. So let's rewrite that first equation. Label that equation 1. It starts off as 3x plus y is equal to 3. I need y equals mx plus b. I need to get rid of the minus this 3x by taking away 3x. Now I have y is equal to minus 3x plus 3. That's the same equation 1, but now it's in standard form. Let's do the same thing with equation 2. We'll call this equation 2. And I'll start with y plus 17 is equal to negative 3x. At this point, I subtract 17 from each side. That leaves me with y is equal to minus 3x minus 17. These are my two equations. Now we can look at it. Now we're back to what we did with problem 23, where we first do what? We demonstrate in a graph, a simple graph, what these look like. Equation 1, intercept is positive 3. I go up 3. I make that choice, the scale, how I'm going to represent 3, in reference to how I'm going to represent the minus 17. I wouldn't want to make 1, 2, 3, and then have to do all the way down for 17. That'd make a very unwieldy graph. So this is my y-intercept for 1. The slope is negative 3, down 3 over 1. That's what that line looks like. That's what line 1 looks like. Y is equal to negative 3x plus 3. For the second line, we go to y-intercept of negative 17. If this is 3, that's 6, that's 12, that's about 17. That's our estimate. That's all we need is an estimate, so we can do a quick drawing like that. Now we have an idea of what we're asking for. We're asking for this perpendicular distance. Perpendicular, that's important. Why? Because I know the slope of that has to be the negative inverse of negative 3. What's the negative inverse of negative 3? It has to be positive. 3 is 3 over 1. Invert it, it's 1 over 3. We know that this equation is y is equal to 1/3 x plus b is unknown. B is not really unknown. We're going to see that when we calculate the b is negative 17, but we're going to state for this to start off with that b is unknown. Why do we say that? Because we know that that point there has to be 0, negative 17. That's the y-intercept of both of them. So we did the calculations in 23 where we found that b is equal to negative 17. So I'm just going to say that b is equal to negative 17. If you need to go back and look at all the calculations from the previous equation. You could plug 0 into this, negative 17 to this, and you see that this goes away. So the actual equation of that line is y is equal to 1/3 x minus 17. It agrees with our picture. They intersect, and that it's a positive slope, not a negative slope like negative 3. As before, we're trying to find a distance. We have one point. What do we need? We need a second point. Once we have a second point, it's a simple distance formula. Distance is equal to the square root of x2 minus x1 to the second power plus y2 minus y1 to the second power. We need that point. This point, this second point, is an intersection of line 1 actually, and this perpendicular line. The intersection of these two equations. Let's write those two equations down here. What are we working with? Y is equal to negative 3x plus 3, and y is equal to 1/3 x minus 17. Set them equal to each other. Minus 3x plus 3 has to be equal to 1/3 x minus 17. Get everything on the same side. I'm going to add 17 on this side. Add 17. I have minus 3x plus 20 has to be equal to 1/3 x. Add 3x on this side. Add 3x on this side. 20 has to be equal to 3 and 1/3 x. This is a mixed number. 3 times 3 is 9, plus 1 is 10. Therefore, 10/3 x has to be equal to 20. To get rid of a fraction, we divide by a fraction. to get rid of multiplication, we divide. Dividing by a fraction is the same as multiplying by the inverse, as we did last time. So it's multiplying by 3 over 10. Multiply this by 3 over 10. We did this to cancel. It goes away. We have x. 10 goes into 20 2 times. That's not the second power, that's division. 2 times 3 is 6, x is 6. We now need to find our y. How do we find y? By plugging the x you have found into either of these two equations. Both of these will give us our answer for y. 6, let's plug it into this equation, since that's the equation of the perpendicular line. It doesn't make a difference which one you do. So using this 6, y is equal to 1/3 x minus 17. Y is equal to 1/3 6 minus 17. Y is equal to 2 minus 17. Y is equal to negative 15. Let's see if this is true for the other, because we said it would be true. Let's try the second equation. Y is equal to negative 3x plus 3. X is 6. Y is equal to negative 3 times 6 plus 3. Y is equal to negative 18 plus 3. Y is equal to negative 15, showing that either equation you use, you get the same answer. We now have our 2 points, allowing us to use the distance equation. What are our 2 points? Point 1 is 0, negative 17. Sorry, keep that on. x1, y1. Point 2 is x is 6, y is negative 15. 6, negative 15. Does this agree with our graphic illustration that we went over 6 and down 15? Yeah, this seems consistent. Now we can find the answer. It's this distance is equal to the square root, this is x2, y2 of 0 minus 6 squared plus that's x1 minus x2 minus 15 minus 17, which is plus 17. 0 minus 6 is 6. 6 squared is 36. 15 minus 17 is 2. It's minus 2 squared is 4. That's 4 plus 36, the square root of that. So the distance is equal to the square root of 40. Leaving your distance underneath the square root, that's fine. You can put it into a calculator and you can get 36.2 or something like that. That's also fine, but it's really unnecessary. Thank you.